Hi everyone, welcome back to our channel MPEEDU. This is Rama Obrat, chemistry lecturer. In the previous video, we discussed the following matters like characteristic of solids and classification of solids. Classification of solids are based on the arrangement of particles. These are classified into two types. One is crystalline solid and the next one is amorphous solid. Crystalline solid particles are orderly arranged. In amorphous solid, particles are disorderly arranged, and their differences are we discussed. And the next important discussion is the classification of crystalline solids. Crystalline solids are classified into three types based on the particle nature. These are molecular solid, ionic crystalline solid, and atomic crystalline solid. In this video, we discussed about a unit cell. Unit cell is a part of a crystal lattice. Therefore, there is a need of study of unit crystal lattice. Crystal lattice. A crystal or crystal lattice is a solid material that contains atoms and groups of atoms arranged in highly ordered structure. This structural arrangement is three-dimensional. So important thing. It is three-dimensional arrangement. So in this diagram, we can see the three different axis. One is x-axis, y-axis, and the z-axis. So this is the three-dimensional arrangement of particle in which particles are orderly arranged, highly ordered structure. Therefore, crystal lattice is defined as regular three-dimensional order arrangement of particles. The particle may be atoms, molecules, or ions. In the crystal, we can see a small portion or a part or a unit. This is the smallest unit in the crystal lattice. This one is repeatedly joined and that one become the big crystal. Therefore, this smallest portion of the crystal lattice is the unit cell. Today class we discussed about this one, that is the unit cell. It is the smallest repeated part of a crystal. Then what is unit cell? Unit cell is the smallest repeated unit of a crystal in a three-dimensional which show the full symmetry of the structure. Important. Okay. The unit cell is explain the symmetry of the crystal lattice. Whatever the type of symmetry is observed in the unit cell, the same symmetry is observed in the big crystal also. That crystal is made up of the same unit cell. I'm consider small unit cell. Don't concentrated on the shape of the unit cell. It may be in any shape. In this unit cell, we can see x and y, z axis and then z axis. So three-dimensional structure, and unit cell contains important parameters. These are three sides and three angles, totally 6 parameters. The three sides are commonly we represent A, B, and C, and the angles are represented as alpha, beta, gamma. These parameters are important to study of the symmetry or the geometry of the unit cell. Therefore, Based on the parameter, these six parameters, unit cells are classified into seven types. For the study of seven types of unit cell, these parameters are important. Simultaneously, the symbolical representation is also very important. The symbolical representation is A, B, C, alpha, beta, gamma. Nothing in this, nothing important in this part. But when you go inside the unit cell, the representation of A, B, C, alpha, beta, gamma is also very important. In this diagram, it clears that the angle created by A, sides A and B, here angle or sides A and B, that creates one angle. This angle is opposite to C. Therefore, this angle is represented as gamma. Opposite to side C is gamma. Similarly, opposite to B means angle created by A and C, it is beta. And opposite to A, angle created by C and B. Okay, that one is known as alpha. So symbolical representation is also important. Please remember this thing. Opposite to A is alpha, opposite to B is beta, opposite to C is gamma. These six important parameters in the unit cell. We just observe the one animated diagram of unit cell. Yes, this is the one unit cell. It is a three-dimensional shape or structure. It has three important angles and sides. When this unit cell is join another unit cell or a several unit cell, that leads to formation of a big crystal. This is the crystal or crystal lattice. It is made up of unit cells, and the pink colored spheres, these are the particles. Particles are highly orderly arranged, and this in this unit cell or in this crystal, you can see another crystal also. So whenever a large number of unit cells are joined, so this is the big crystal. Okay, it's a three-dimensional view. This is the small crystal lattice. The pink colored sphere, it is the position of the particle. It is known as lattice point. It is known as lattice point. And in this crystal, this portion is a one unit cell. One unit cell, and there are 8 unit cells are present. 1 2 3 4 5 6 7 8. There are 8 unit cells are joined in this crystal. Okay, now what is lattice point? Lattice point, it is a point which represents the position of the constituent particle. Particles may be atom, ion or molecule in the crystal. So in this part we are discussed three important things. One thing is, what is crystal lattice, and the next is, what is unit cell, and next is, lattice point. Okay, let us move to the next part. What are the 7 types of unit cell based on these 6 parameters A, B, C and alpha, beta, gamma? The first is cubic lattice or unit cell. Cubic lattice means cube is the three-dimensional view of square. Therefore, all the sides are equal. Sides are represented as A, B, C. A is equal to B, B is equal to C, and all the angles are 90 degree because it is a cube. Alpha, beta, gamma, these are equal to 90 degree. And example for cubic crystal lattice or unit cell is sodium chloride or a zinc blend, zinc sulfide. It is generally we call it as a zinc blend. The next type of unit cell is tetragonal, in which uh, A is equal to B but not equal to C. One side is larger than that of other two or smaller than that of other two. Alpha, beta, gammas are 90 degree, and example is white tin and calcium sulfate. The next example is orthorhombic, orthorhombic unit cell. In this case, A is not equal to B, not equal to C. All the sides are different, and alpha, beta, gamma all are equal to 90 degree. It is the example for orthorhombic is the allotropies of sulfur. One is rhombic sulfur. Next example is barium sulfate. It look like a matchbox. In the matchbox, all A is not equal to B, not equal to C, but all angles are 90 degree. Yes. Okay. Next example, next type of unit cell is monoclinic. In this case, A is not equal to B, not equal to C, similar to orthorhombic. Sides are similar to orthorhombic, but one angle is not equal to 90 degree. Example is graphite. Graphite is the sorry, it is not a graphite. In this case, monoclinic sulfur. Monoclinic sulfur is the example. Rhombic sulfur is example for orthorhombic, and monoclinic sulfur is example for monoclinic type of unit cell. Okay, next type of unit cell is triclinic. Triclinic, all the sides are different and alpha, beta, gammas are not equal to 90 degree. Example is calcite or K2Cr2O7, K2Cr2O7, or copper sulfate is also example. Okay, the next type of unit cell is hexagonal. Hexagonal structure. Hexagonal unit cell in which A is equal to B but height is not matched with the other two sides. It is different from A and B, and alpha beta is equal to 90 degree, gamma is equal to 120 degree. It is a three-dimensional view of benzene ring or cyclohexane. And the next example for hexagonal is graphite. Graphite is the example. Okay. Next type of unit cell is rhombohedral. Rhombohedral, in which A is equal to B is equal to C, alpha, beta, gamma is not equal to 90 degree. Example is calcite. Okay. K2Cr2O7 potassium chromate is example for triclinic, and copper sulfate is example for triclinic. In out of 7 unit cells, triclinic, A is not equal to B, not equal to C, alpha, beta, gammas are not equal and not equal to 90 degree. Therefore, it is highly unsymmetrical. Remember this thing. And cubic is highly symmetrical. It is highly unsymmetrical. This part is very important. Better to take a screenshot of this slide, and this is very important for your competitive exam. Okay, next we move on to the classification of unit cell. The classification of unit cells are 7 type based on the parameters. Okay, next is based on the arrangement of the particle. Arrangement of the particle. Arrangement of the particle in the unit cell. The unit cells are classified into two types. One is primitive or simple unit cell. Another one is centered unit cell. Okay. The primitive unit cells are not further classified, but centered unit cells are further classified into 5 different types. One is body centered unit cell, next one is face centered unit cell, edge centered unit cell, the last one is end centered unit cell or face end centered unit cell. Okay, so these are the 5 different types of centered unit cell. Out of 5 centered unit cell, the cubic unit cell, okay, cubic is very important for your study. Cubic unit cell is very important. It is the very important part of your second year syllabus. The cubic unit cells are shown 3 different types of centered unit cell. There are 3 possibility. There are 3 possibility in the cubic unit cell. And compared to or when we observe all these 7 unit cell, there are 14 possible structure or shapes are there. These are known as previous lattice. This thing is very important for your competitive exam. It is not important for your theory exam part. That part will be discussed in the CET classes. Okay, we are going to study about only cubic unit cell. Cubic unit cells shows 3 important unit cells. These 3 important unit cells are, one is primitive unit cell, the next one is body centered unit cell, and face centered unit cell. Therefore, primitive, body centered and face centered unit cell is very important. Let us discuss about what is primitive unit cell and what is body centered and what is face centered unit cell. Just observe this diagram. The unit cell in which particles are present only at the corner of the cube. Only corner of the cube. We can see the particle only at the corner. So this is the actual diagram of the primitive unit cell. Okay. The next one is body centered unit cell, in which there is a one particle at the center of the body. It contains corner particle. With that, there is a one particle at the center of the body. So this is the actual diagram of the body centered unit cell. The next one is face centered unit cell. Face centered unit cell means particles are present at the corner. Just look at this diagram. The particles are present at the corner. In addition to that, each faces contains a one particle. That particle present exactly center of the face. Therefore, it is a face-centered cubic lattice. It is completely cube. It is cube and cube. In these cubic lattices or unit cell, there are 3 possible arrangement of particle. Particle only present at the corner, then it is primitive or simple. Particle present at the corner, in addition to that, particle present at the body or center of the body, then body centered cubic lattice. The last one is face-centered cubic lattice. Particle present at the corner. In addition to that, each center of the faces contains a particle. The important part of these cubic lattice is calculation of number of particle present in a different cubic unit cell. Okay, I am consider first unit cell, that one is primitive or simple cubic unit cell. The definition itself says particles present only at the corner. Yes, particle present only at the corner. This is the according to the definition, there are 8 corners in the cube and each corner contains a particle. Then how much particle? What is the need of calculation? And how many particles present in a cubic unit cell? When you observe generally, or when you observed the primitive unit cell, there are 8 particles. Not actually. It contains only 1 particle. How it is? Okay, we just see the one animated video, then it clearly indicates how many particles are present in primitive unit cell. Dear friends, this is the cubic unit cell. The actual shape of the primitive unit cell is this one. Particles are present only at the corner. When we join the center of this particle spheres, when we join the center, then we got a primitive unit cell. Yes, this is the primitive unit cell, particle present only at the corner. The center of the sphere become the corner of the cube. Okay, this is the actual picture of the primitive unit cell. Inside the unit cell, how many particles? Okay, so inside the unit cell, this much, only this much. How many particles are present? This is the one smallest portion of the big sphere. How much part is belongs to this unit cell? Only one small portion of the sphere or particle belongs to this unit cell. Similarly, in the another corner, similarly in the all 8 corner, there is only smallest portion of the sphere is belongs to unit cell. When we join all these portions, then it gives the total number of particle present inside this unit cell. Then how much part is belongs to this unit cell? In one corner, I am consider one corner. In this case, there are other unit cells. How many unit cells are there in the corner? 1, 2, and above this 2 unit cell there are 2, 3, 4. Similarly, in front of this 5, 6, above 7, 8. There are 8 unit cells attached in this corner. Therefore, one sphere or one particle which is contributed to 8 different unit cells. Therefore, one sphere is cut off into 8 equal part. Therefore, only 1/8 of sphere or particle belongs to one corner. How many corners in one unit cell? Exactly, it is 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. In every 8 corners, we observe the 1/8th portion of the particle. Therefore, total number of the particle is equal to 8 get cancelled. It gives 1. Inside this unit cell, there are only one particle. Sorry, there is only one particle. Okay, the other unit cell will be discussed in the after calculation. Okay, come to the calculation part. In your exam, suppose the question is asked, calculate the total number of particles present in the primitive cubic unit cell or simple unit cell. Then you should draw the diagram clearly. You should first draw the cube, and you should represent the particle present at the corner. And the next thing is, what is primitive unit cell? It contains 8 atoms or 8 particle uh, each corner, and therefore total number of the particles becomes. How can you calculate this one? Using this formula, the corner into contribution of the corner particle. How many corners are there and how much contribution given by this particle. Okay, the next, how many corner per corner? Yes, 8 corner in the unit cube, and contribution of each corner particle is 1 by 8. Therefore, it is 1 particle. It's very simple. This type of question will be asked for 2 marks in your annual exam. Therefore, this part is very important. The next unit cell is body centered unit cell. Okay, body centered unit cell. I think you are already guessed what is the answer for this one. Total number of particle present in the body centered cubic unit cell. Okay, let us move on to the calculation part. The calculation is total number of corner and contribution of the corner particle, and plus there is a one particle present at the center of the body. Therefore, it become how many corner in cube? Yes, exactly, it is 8 corner, and contribution is 1 by 8, and 1 plus 1 particle present at the center of the body. Therefore, it gives how many particle? 8 get cancelled, gives 1, and 1 plus 1, which is equal to 2 particles. There are 2 particles present in the body centered cubic unit cell. Okay, and then last one, the remaining unit cell is face centered unit cell. In the face centered unit cell, how many particles are present? Okay, just once again, you can see the animated diagram. Yes, this is the face centered unit cell. Okay, in 3-dimensional view, it clearly indicates how particles are arranged. Each corner there is a particle, and each center of the faces there is a one particle. Then what is the contribution of face particle? Anybody can guess? We already discussed the contribution or the attachment of the corner particle with the unit cell. The corner particle attached to 8 different unit cells, therefore contribution is become 1 by 8. I think all of you understand this thing. Then how many faces are there? Faces are there in the face center cube, and what is the contribution of the face particle? Yes, it is half. Why? In this diagram you can see this one, face centered particle, which contribute to half portion to this unit cell and half portion to another unit cell which is present exactly above this unit cell. So therefore only 1 by 2 or half portion is belongs to this unit cell. How many faces in cube? There are 6 faces. 1, 2, 3, 4, 5, 6. In each faces there is a half particles. So therefore totally it becomes 6 into 2. Once again I uh, give the explanation by considering the actual face centered unit cell. Okay, this is the actual face centered unit cell. In a three-dimensional view it look like, okay, this is the face centered unit cell. And when we observe the only the unit cell, other parties belongs to other unit cell, the particle parts, but half portion belongs to this unit cell. 1 by 8, 1 by 8, 1 by 8 corner particle is already there. Okay, so by considering this, clearly indicates the half portion is belongs to this unit cell. Face center particle contribute half. Okay, move on to the calculation part. Okay, okay, yes. In the calculation part, total number of corner, contribution of corner particle, because in face center corner particles are there. In addition to that, face center particle. Therefore, in addition to that, total number of faces and contribution of face particles. How much? Okay, yes, 8 corners. 1 by 8th part is the contribution of corner particles, and there are 6 faces, and contribution is 1 by 2. Therefore 8 into 1 by 2 plus 6 in, sorry, 8 into 1 by 8 plus 6 into 1 by 2, totally it become 1 plus 3 particles. Therefore total 4 particle is belongs to this unit cell. Inside the unit cell there are 4 particle. How it is? From corner 1 by 8th contribution, it gives 1 particle, and half, 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 and half. So there are 6 faces. Each faces contribute half, total 3 particle. From faces, totally 4 particle present in the face centered unit cell. So this concept is very important. Calculation of number of particle. Okay. Thank you for watching this video. In the next video we discussed about the very important concept, that is packing efficiency of these 3 different unit cell. Please like the video and subscribe our channel and share the video as much as possible. Thank you once again.